Another important aspect is, of course, directivity and sound focusing. In most applications, we have conventional systems, and conventional electrodynamic loudspeakers have a wide range sound radiation, which is also preferable. But in different applications, we need also some sound beaming, sound focusing. In that case, we would like to radiate sound only one direction and, for example, only give this information to one person, not to the whole environment. Therefore, we need, in that case, sound focusing. And for such cases, electrostatic loudspeakers or ultrasound or loudspeaker arrays are quite interesting. Today, as I already said, that I will talk about electrostatic loudspeakers. And if we look this slide and check the electrostatic transducer, actually they will be applied not only for electrostatic loudspeakers, also for condenser or capacitor microphones. And in these transducers, we have two electrically conductive plates with a distance of L, and the right plate is movable, as you can see with this spring, and the left plate is fixed. If we charge in opposite polarity these both plates, of course, we can take into account the electric capacitance between two electrically conductive plates. And this electric capacitance can be described using the electricity constants and also the area. And of course, distance between the plates. As I already said, that this technology will be used mostly in electrostatic loudspeakers. Already first commercial products are very old, 1920s. In this case, actually, we have a sandwich type construction and three basic components. As you can see in the picture, we have two stators, and in the middle of stators, we have a diaphragm. And this diaphragm is flexible between these stators, and steady positive charge on the diaphragm, and at the same time negative charge on the stator cause that the stator cause a pull of this diaphragm. Other stator is charged positively, therefore it push this diaphragm. In that case, diaphragm moves in this direction, and of course, if we change the charge, at that case, it begins or it starts push and pull operation. And therefore, of course, a constant bias voltage in the diaphragm is applied. And as I already showed that here, in electrodynamical loudspeakers, our aim is, in most cases, spherical sound radiation. But in electrostatic loudspeakers, as you can see from the functional principles, in most cases, of course, we have plane wave type sound radiation, therefore also good focusing. Therefore, we have conducted some measurements in our laboratory with an very good electrodynamic loudspeakers and at the same time electrostatic loudspeaker. And in these pictures, you see the degree, and at the same time with color, the radiation aspects, and frequency axis is the x-axis. And you can see that in first case, electrodynamic loudspeaker case, we have very broad degree of direction from 60 degree to minus 60 degree. But if you look electrostatic loudspeakers, particularly in higher frequencies, we see that it is much more focused. We are now in front of the anechoic chamber of Technische Universität Dresden. We conduct various electroacoustical investigations in this laboratory. It allows us free field conditions. All walls and floor are designed to absorb sound energy. Therefore, we have these edges which were filled with glass wool. At the same time, because of the floor, of course the edges, we have a wire mesh, and this wire mesh cause, if we walk, it is like a trampoline, and therefore we have also some shaky pictures at our camera shot. Now I would like to demonstrate the directional characteristics of an electrostatic loudspeaker. As I already explained that, they have very focused radiation. Therefore, in this demonstration, I will use a microphone. The position of the microphone will be constant, but I will rotate the loudspeaker. Therefore, if it is in opposite side, you will hear the music or sound signal. If I change the position, you will not hear anymore. As I already said, that this transducer principle can be also applied for microphones and is used, it is for us quite important because electrostatic microphones or condenser or capacitor microphones is used as standard measurement microphone and also as hi-fi studio microphone. Therefore, I have selected this microphone type. The main advantage is high dynamic range and at the same time wide linear frequency response. In that case, the electrostatic microphone consists of a thin membrane, which we can see. In a small distance, there is a backplate, also in this picture we see. They are both electrically insulated from each other and they form an electric capacitor, and the holes in the backplate form an acoustic resistance that serves to damp the membrane at resonance. Such kind of technologies also applied for headphones and earphones, but non-depending on the technology, I would like to categorize headphones and earphones depending on circumaural or supraconcha, which we see in this categorization. Of course, there are closed type headphones and open or semi-open type headphones. In closed type headphones, we have a big advantage that we can insulate, of course, from the background noise, but open or semi-open type headphones are quite interesting for augmented reality applications. And the main advantage of these systems, in most cases, we don't have any influence of the room or environment. At the same time, small volume velocities, which can be generated better, and therefore there are not so a lot of non-linear distortion problems like loudspeakers. Of course, most of the loudspeaker technologies which we saw already can be used for the systems like electrodynamic, electromagnetic, or electrostatic systems. In the beginning of the lecture, I said that, of course, we expect that wide linear frequency response from the electroacoustical systems. But if we take into account the headphones, we should, of course, take also account head-related transfer function, because in that case, of course, we have very near loudspeakers to our ears. And therefore, in most cases for headphones, it is better to have at higher frequencies amplification of some frequencies. Here you can see from the literature HRTF measurements from the frontal or diffuse field measurements, and you can see that particularly in between 2 and 8 kHz, there's an amplification. Therefore, most of the loudspeakers in this frequency range have some higher level of frequencies. And the other aspect, of course, if we listen with only one ear, it means that there is a loudness difference. And if we listen with 2 ears, this is the difference of 10 decibel, which is very meaningful. Therefore, also, if we use headphones or earphones, should be taken into account the loudness. I would like to finish my lecture with some recent developments in this field. Of course, there are a lot of research in this field. I will show only 2 of them as an example. Also in my literature, you can find some other developments. First of all, I would like to introduce a new loudspeaker driver technology, the electric elastomer. In my team, we try to change the system using the electric elastomer, and the electric elastomer have good possibilities, of course, without using any magnet or any high mass to generate sound. At the same time, in second example, we see new ideas to produce new membrane or cone materials. In that case, as I already said, that we need some light and stiff materials, and therefore graphene is a very interesting object because extremely low mass density and high mechanical strength, which will be introduced by Sue and Settle. I would like to finish this lecture with my references, which you can find in my slides. Thank you very much for your attention.